at page 140, and let's look at a couple more examples. So our next structure contains two fluorines. So step one, draw the dot diagrams. Both fluorines, same type of atoms, both come from group 17, meaning they each have 7 valence electrons. And when you take a look at it, this is this fluorine's only single electron, and right there the second fluorine. So since they each only have one single electron, each one can only form one bond. Because these two atoms are of the same type, they have the exact same electronegativity, they can only form one bond. There is only really one thing that can happen, is the first fluorine's unpaired electron will partner up with the second fluorine's unpaired electron. And when we go and draw this, between the two fluorines we put the dashed line to represent the shared electrons, and then each one keeps 3 electron pairs for itself, so we put that around the outside. And since there's only 2 atoms in this structure, then automatically we should recognize it as linear. Let's take a look at the next example. Okay, so we have the element hydrogen, and hydrogen is in group 1, so it has 1 electron only, and that electron lacks a partner. So the hydrogen needs to form one bond. Sulfur comes from group 16 like oxygen, and because it's in group 16 like oxygen, it has 6 valence electrons. And when you look at its dot diagram, like oxygen's, in its dot diagram, 2 of the electrons are unpaired, so a sulfur has to form 2 bonds. So sulfur is the structure that has to form more bonds. Hydrogen can never be the center. So this is never the center. So in our honk rule, sulfur has to be the center because it forms more bonds than hydrogen. Sulfur is in a group 16er, so it's just like oxygen. So if you look at oxygen, so I'm going to just do this on the side. So oxygen, because it has to form 2 bonds, there are 2 possibilities. So either the oxygen forms 2 single bonds and creates this bent shape, or the oxygen forms 1 double bond and creates this shape. So if you take a look here, hydrogen only has 1 unpaired electron. Its only electron will pair up with one of sulfur's electrons. Hydrogen does not have a capability, this hydrogen does not have the capability of forming a second bond. So that means sulfur cannot be forming a double bond. It's not a possibility. So I'm going to start this drawing. So I have my sulfur, and it forms a bond with the first hydrogen. And because this is not a double bond possibility, then I know that I have to have something else present here. And there's a big clue here. In our information, it tells us that we have a second hydrogen whose dot diagram will be exactly the same as the first one, and its only electron will pair up and form a bond with sulfur's second. So we put the second hydrogen at the end of the other dashed line. Sulfur, like oxygen, it keeps those 2 electron pairs for itself, not to be shared or used in a bond. So we put those on there. And so when sulfur uses this pattern to form a molecule, we refer to it as bent.